We're going to talk about linear functions. This is a lot like linear equations on how we graph it and everything. It's just bringing in functions and a few new vocabulary words. So a linear function is a function in which the graph of the ordered pairs forms a straight line. So y equals mx or y equals mx plus b would be a linear function. So just like we did in chapter 3. A function can be considered continuous or discrete. Continuous data can take on any value, so there's no space between data for a given domain. Discrete have spaces between possible data values. Graphs of continuous data are represented by solid lines. Graph of discrete data are represented by dots. Look at these are just the different ways that you can represent functions, and we've talked about a lot of these. They are you can have an equation, ordered pairs, table, and graph. Then down here it talks about continuous data. So think about continuous data can have parts. So like the number of ounces in a glass. That could be 0.1 ounces, 0.2, point whatever, or 5 ounces of water. It doesn't, you don't know. It's continuous. It doesn't have to be a whole number. Weight of each chocolate chip, same thing. That could be 2.1 or 0.1456. It's continuous. Discrete number of glasses in a cupboard. Okay, those are going to be whole numbers. So there's going to be like 1 glass or 2 glasses. There's not going to be 2.1 glasses. A number of chocolate chips in a bag. We can have parts of chocolate chips, but they're talking about how many chocolate chips are in the bag. So you can determine if the data that model real-world situations are discrete or continuous by considering whether all numbers are reasonable as part of the domain. So think about just if there's parts, does that make sense? So Manuel is saving money for college. He already has $250. He plans to save another $50 per month. Write a function to represent his savings for any number of months. So we have S equals savings and M equals months. So S equals 250 plus $50 per month. Then they want us to make a table. So we have M is our months, and we have 250 plus $50 per month. Then S is our savings. So they want us to do it for 2, 4, 6, 8, and 10 months. 2, 4, 6, 8, and 10. So 250 plus 50 times 2, and that gives you 350. Then we have 250 plus 50 times 4, and that gives you 450. Then we have 250 plus 50 times 6, that gives you 550. We have 250 plus 50 times 8, that gives you 650. And then 250 plus 50 times 10, and that gives you 750. You want us to graph the function and decide whether it's continuous or discrete. So we have number of months, and then we have total savings. So we graph that. 2 is 350, so that would be right there. 4 is 450, would be there. 6, 550. 8, 650. And 10, 750. That's going to be discrete because we're not going to find how much he made for part of a month. We're talking about per month. So it's discrete. You're not finding part of a month. So we want to interpret the graph. So in words, that would be he saved $350 in 2 months, $450 in 4 months, $550 in 6 months, $650 in 8 months, and $750 in 10 months. That would be putting it into words. So that's continuous and discrete with linear functions.